Alright, next page here, we have a rectangle going on here, and with this rectangle, since it's also a parallelogram, opposite sides will be equal. So we are going to go 2x minus 3y equals 12, and then a second equation of 4x plus 3y equals 24. Okay, and I guess the big deal with this one is you have x's and y's mixed into your equation. The only way we're going to be able to do this is like how we did up here on this previous problem here. We're going to have to use substitution or elimination. Now the problem is going to be more geared towards the elimination here, because what can happen is if you add the two equations right now, since you have a negative 3y and a positive 3y, they would just cancel out. And then when you add your x's, you would get 6x, and then over here on the right hand side, adding the constant numbers up, you would get 36. Okay, so this is using elimination this time. After you divide, you do get 6. And then after you do that, I want you to take your 6 and plug it right back into one of the two equations. I'm going to plug it into the first one, but I mean, really, they're about the same difficulty, honestly. So what is this? 12 minus 3y equals 12. So actually, this one's kind of strange here. When you subtract 12 from both sides, you do get 0. That doesn't mean no solution or anything. That just means after you divide, you get 0. And that's totally fine. There's nothing wrong with that right there. You could plug 0 back in and, still get that the side's going to be 24 when you plug your numbers back in. But yeah, that one's using more of the elimination method right there. Looking here at number 12 here, I noticed that the opposite angles here are congruent, so it must be a parallelogram. What we're going to do here, I guess on this one here, set opposite sides equal. And kind of like the last one here, you're going to have x's and y's mixed together. What's nice though is when you set those sides equal to each other, 6 equals 3x. That just means x is 2. So really, it's kind of like you've already done the elimination stuff. We already figured out that x is 2. And then now we can go plug it into this other equation right here. X plus y equals 5x minus y. And we can plug in the 2. So you can say 2 plus y equals 5. Go ahead and plug the 2 into both spots. That's 2 plus y equals 10 minus y. And then I guess we can add the y to one side and then get 2y, and then you can subtract the 2 and you get 2y is equal to 8, and then you can divide, and that's going to be y equals 4. And that should be it there on that one. So kind of a specific case, not necessarily substitution or elimination problem. It's just we could find x right away by setting the 6 and the 3x equal to each other right away. Okay, so next we're going to start throwing in some trapezoids here at you. First of all, since these angles here are congruent, that implies that this is an isosceles trapezoid. So as far as solving for the sides, if it's isosceles, then we can just go ahead and set these guys here equal to each other. I can subtract over 10x, that's going to give me 6x. We can add 24, that's going to give me 36, and then we can divide, and that's x equals 6. So that's how you find your side for that. We can use that. Now, I think they also ask us for some of these angles here. Yep, they do. So remember, with isosceles trapezoids, the angles here are going to be the same here, those two base angles, and then also these two base angles will be the same. It's both pairs. So we can put 114 right there for that angle. And then since the sides are parallel, since it's a trapezoid, we can say, hey, the two consecutive interior angles need to add to 180. So we'll go 180 minus 114, and that gives us, what is that, 66 degrees. And then since it's isosceles, that must also be 66. And then you can check, make sure all of your angles add up to 360 since it's a quadrilateral. That's going to be it there on that one. For number 14, you have what's called a mid-segment, and here's what you need to remember about the mid-segment. The mid-segment, first of all, it connects two midpoints, and the mid-segment is basically, it's just an average. And remember, to find an average of something, you add the two bases, and then you're just going to divide it by 2, and that's your mid-segment. So this is kind of like your mid-segment formula, specifically for trapezoids. It's a little bit different than the mid-segment formula that we learned a couple weeks ago dealing with the triangles. So all you do is average them. So how do we do this one here? We go 6 plus 16, the two bases, divide that by 2. That equals the mid-segment, or that equals 2x minus 11. Okay, now 6 plus 16 divided by 2, that's going to be 22. And then 22 divided by 2, that's going to be 11. And then, whoops. And then we can go ahead and add the 11 to the other side, or really to both sides. And then divide, and that happens to come out to where x is 11. And that's the big idea there. So if there's anything you need to study or memorize here for this test here on that specific problem, is that the mid-segment is an average. Okay, I think we got some more of those coming up here, some more with the algebraic expressions. So let's tackle those and see what's going on here. With algebraic expressions, a little bit more involved here. And notice here, yeah, you got, these are your two bases. So the way you'll write it is 5x plus 3, that's the first base, plus the other base, 3x plus 5. All of that divided by 2, and then equals 7x minus 8. Okay. What I would do first is actually combine up your like terms in that numerator. That would be 8x plus 8 divided by 2, and then equals 7x minus 8. Now from here, there is two approaches that you can do to solve this. One way you could do this here is you could multiply. Here, let me copy and paste it here since I'm being lazy. So one way you could get around this here is multiply both sides by 2 to get rid of the fraction. But when you do that, you have to multiply the entire right-hand side. Over here on the left-hand side, the 2's cancel out, and then you're just left with the 8x plus 8. And then when you distribute over here, this would be 14x minus 16. And then you just, go get x by itself. 6x, add the 16, that's 24. That's x equals 4. Now, if you don't want to do the multiply both sides by 2, as long as these two numbers in the numerator are both divisible by 2, you could write 4x plus 4 and then equals 7x minus 8. Basically, I just divided both of these things individually by 2. And then when you subtract, you get 3x, and then when you add, you get 12, but you still get x equals 4 here at the end. So two approaches there on that one when you start to solve it all, and that'll be it. Okay, so I usually, well, yeah, I guess it just depends on the problem. If they're not divisible by 2, you're probably going to have to do this method over here. So I'm not sure how it'll come up on the test, so just be ready for both methods, and you should be pretty comfortable. Same idea on this one, 6x, and then plus the 2x plus 4. All of that divided by 2, and then equals 14. I would multiply both sides here by 2 to cancel those out, and then that's 6x. And here, let's do this here. 6x plus 2x is 8x. And then, of course, 14 times 2, 28. That would be 8x is equal to 24, and then x equals 3 here after dividing. And that'll be it here on this page.